going to talk a little bit about love and worrying too much, perhaps.
All right, how you guys doing? You hear me? Oh, there it is. All right, so my name is Ryan Anguiano. I work for a little startup called RevPoint Media. We're based out of New York. And let's get started. So we're here to talk about microservices. So I have a couple of caveats first. You should not use microservices just because you want to. You should only use them because you need to. Now, let me give you a little bit about how I got into microservices. So it's about the third iteration of our company software at RevPoint Media. First was proof of concept. You get all the quirks out of the way. Second is the first production build, and that was the giant piece of software that we took our proof of concept, put it into production, and just got massive. If you want to see how massive, here's our monolith right here. I'm just kidding. No, but here's what the file structure looks like for our monolith. This was our second version of the software. And these are just the Python files. I didn't even open the template folders with all the HTML front-end files and all the JavaScript and stuff. So, when you get to this point, that's kind of when you want to start looking at, maybe now we can start looking at microservices. Anytime before this, it's really hard to, if you want to pivot your business, like if you want to change any business decisions, after you already start implementing microservices, it's really hard. You really want your core business logic to already be flushed out. So once you have that done, then it's finally time to start looking for microservices. And our monolith was a very large Django app. You're stuck in old Python. We started this 5 years ago, so 2.7 was the Python we were on, and you can't put Python 3 code and Python 2 together, so you're kind of stuck with your old Python code. Even for launching another copy and just wanting to run a little part of your code, we have to have, I think it's 88 dependencies in a requirements file, and it makes it really hard to deploy and get all that correct. And when you want to do a deployment, it takes down the entire app. So it's not very, when you get larger and larger, it makes it harder to be nimble and be continuously deploying. So the first thing you want to do is you want to take your monolith and you want to break it up. So how do you do that? So you want to analyze your data flow and divide it into logical services. And you kind of just, the things that are a mess, all the intertwined code, you can just leave that for now. You really just want to concentrate on getting the most obvious pieces, like your accounts, locations, just things that can just be broken off. And so here's an example of that. So here's the monolith with all the different components right here. And you can see there's a bunch of core logic, there's some messaging, there's some accounts, and you want to analyze that and see which parts of your app are talking to each other. And once you kind of just figure it out, you can see, accounts talks to this talks to accounts, and you can kind of structure it and organize it. And so once you see how everything's kind of connected, you can kind of see where the boundaries are and where you want to separate them out. And you can see you want to make each microservice as small, contained around as little logic as possible. So you want the core logic of each service. And microservice is not necessarily, they don't have to be micro. You can see the one on the right, it's the main core logic, but since the three main core logics are intertwined, it's going to be really hard to break them up. So we can see that core logic D, okay, that doesn't really interact that much with the other one, so that's really easy to separate. But the three that are really intertwined and talking to each other, you'll probably turn those into services in way later iterations. And it's also really hard to have business logic when you're first building that's split up amongst all your different services. So I say that just keep your core business logic intact, and you start just breaking little things off, and you'll get to the big stuff later. So after you kind of analyze your app, you want to build a migration roadmap. And there's lots of different tools. You can spend months and months and months researching all the different tools that microservices have to offer. And there's lots of different competing thoughts, processes, and the thing that you really want to care about is each tool has its own purpose, and your business has different purposes and they need different tools. So you really want to not just go with what everyone says, oh, this is what you should do, or this is what's cool. You really want to evaluate all the different tools and find what is exactly going to solve your business problem. And so, there's Docker, Mesos, Consul, Kafka. If you really want to see a really good example, I would check out Mantle. It's kind of a framework that takes a collection of all of this infrastructure and puts it in one easy app that you can just launch. You can either launch it in a Vagrant box and run it on your machine, or with a couple lines of code, you can easily launch it into AWS or Google Cloud. And it's pretty much a pre-boxed microservices toolkit. And so that's pretty much what I would say if you have no idea what you're doing and you want to start. Mantle was actually initially created by Cisco, and they did a really good job of making sure that it's really easy to get up and running, and you can pretty much launch everything just with a couple keystrokes. So that's pretty nice. So after you look at getting the infrastructure and your tools, you want to look at what are the different methods to design your services so that they can talk to each other. And the very important thing is you don't want you want all your services to be able to talk the same language. So there's really two types of communication. There's synchronous and asynchronous. And so synchronous, obviously you need a response right away. And asynchronous, you can just send a message off and forget about it, and other things are going to be doing their thing. So those are really the two types of communication in microservices. And you really want to narrow it down to two basic ones. So the ones that I chose for our system are HTTP REST for synchronous and Kafka messages for asynchronous. And don't worry about Kafka if you don't know what that is. I'll get to that in a minute. So we settled on those two for how to communicate. So everything in our system either uses HTTP REST or Kafka messages. And those are the only two ways that everything can communicate. Another thing is the 12-factor app is a really good guide. It pretty much tells you how to declare all your declarative configuration, dependencies, config files, external resources, revision control. It's kind of just best practices. Most people kind of understand most of it, but it's just kind of a checklist to make sure that everyone's on the same page with what you're supposed to be doing for microservices. And again, it's not the Bible, it's just a guide. So take advice at will. When you are designing your API, you can always make changes to your endpoints, and the endpoints should always stay relatively static. If you are going to change the endpoint, make sure it doesn't break. So if you're going to make a breaking change, either make it version 2 of that endpoint or make it a completely different endpoint, because if you have different customers of that API that you're not in charge of, you want to make sure you're not breaking anyone else's code. So you really want to make sure that every time you make a change to an endpoint, you're always testing the old versions of the endpoint to make sure that those work as well. Okay. Another important thing is you want to separate your data stores. You don't want everything to be accessing a single database. That's just bad, because if you have multiple teams accessing a database, someone makes a change to one of the tables, and it just has very, very bad side effects. And so if you do have a database that needs to be shared amongst multiple services, you really kind of just want to put a REST wrapper right around the database. So you really don't want to be doing stuff like this. The accounts is correct, and you really don't want to be doing, like, the billing and reporting are both going into the same database. What you should be doing is putting a transactions wrapper around the transactions database, and everything can access that data through the API. And the reason you want to do this is to just guarantee that that endpoint of that data is always going to be the same for every piece of software that's looking for that data. Another thing you want to do is create a tool set for your software. So you're going to be creating anywhere between 5 to 10 to 20 to 40 microservices, possibly even more. I think Amazon does thousands, and you're going up to infinity. So you really have certain things that are guaranteed to be in every app. There's authentication, there's messaging, there's log settings, there's all your middleware. So you really want to spend some time to just think about all the things that is going to be in every single app and build your own package that you can deploy and you can just pip install on all of your other services that you're running that takes care of all this. An example is I have a Backend API object that I put on all Django requests. So if I have a view with the request object, I can call request.backendAPI, and it's actually just a wrapper around a request session. So it's a request session with a whole bunch of setup. All the things that I was talking about in the previous slide, it pretty much goes and sets that all up so that everything is automatically correlated. Instead of having to know where the service is, I can pass a tuple where the first value is always the service name, and then the next couple values are the endpoint in that service. And so this was just something that we decided, but you can customize it to be however you want. You really want it to be as easy for every single service to just be able to talk to each other. So you want a new developer to be able to come in, say, I want a service that does this. They would just be, oh, okay, and just request the data and be able to access it. And so really, those are the kind of things that you want to put in your toolkit. Another thing is infrastructure design. So we use Docker to be able to generate the same environments as our development and our production. So there's a guarantee that whatever is running inside the Docker container is always the same. If it's always the same, you're never going to have any issues where you're uploading your app and it breaks because of requirements or anything like that. So we use that. We also use Mesos and Marathon to deploy all our apps. And those are all inside the Mantle framework that I referenced earlier. So if you really want to take a look at the infrastructure, just go look at that Mantle project and download it and take a look, and it really gets you started really easily. Another thing is you want to be using continuous integration to deploy your apps. You want your apps to always be tested and always be automatically deployed. Now, this isn't necessarily required in all microservice frameworks, but this is something that I found and I really, really, really like. This changes a lot of things. So we use a centralized data pipeline, which is built on top of Kafka. We actually use the Confluent version. They're the company that actually develops Kafka, but they have their own open source version as well as an enterprise version. And it comes with a whole bunch of tools. And this is the asynchronous data messaging that I was referencing earlier. So I'll give you an example of this. So most of the time when you write an app, this is what a proof of concept web app looks like. You have your web app, talks to your database, you put it online, it's ready to go. Usually works right out of the box. But then once you start getting into production, you start having a cache, you start having search, reporting, workers, and you have to manually connect all of these. You have to go, okay, when I update the web app, I either want to also update the cache at the same time, or I want to have a worker follow the database, and anytime it sees something, then I have to update the cache. And there's just all these connections that they get really complicated really fast. And when you're in production, business needs push you to add more features and more infrastructure, and you can imagine just the intertangledness of all your services and resources. So instead of having to go through all this, you really want to structure everything so that you have a centralized data pipeline, and everything pushes all data into your centralized data pipeline. And so what this means is, if I update my web app and I update the database, that gets sent through the data pipeline. Anything that wants to know when an update was made just has to follow that topic in Kafka. And you can, the nice thing about this is, you do not have to plan for any future applications that might ever need that data. Once you put it into the centralized data pipeline, it's there. And anytime you need a new service that does something with that data, it's there. So it's not like before, where you had everything intertangled and you needed to save to database and update your cache. It's just all, you feed it all into the pipeline, and whatever you need, you can go and look it up. All right, so now another important thing, logging and analytics. So we send all our logs into the data pipeline. We send all our Docker logs using software called LogSprout, and it's just a little Docker app that sits on every machine and sends all the information of all the logs from all your services into Kafka, tags them with the container name, tags them with the service, and you can go back and you have every single log that goes through Kafka, and you'll have access to it. We also have our syslogs from all our systems being dumped into Kafka. And the other thing about Kafka I probably didn't reference earlier was, so it's a distributed log system is really what it is, that you can build a lot of things on top of. And you can really say, I only want to store the last 7 days of this topic, or I only want to store the last 100 megabytes. You can really customize each topic to be whatever you want for that purpose of that topic. So for logs, we usually only save the last 7 days. And then we have workers that read Kafka and save all that data into S3. And so that's our archive of all our logs. So Kafka is just really, it's kind of like just a large buffer. And you can use, MQs, you can use ActiveMQ, RabbitMQ. But the reason why I really like Kafka is because you can save that history. So if you ever need to go back or rewind, it's always there. Another thing in your logging is you want to generate correlation IDs. So I'm going to call these CIDs. So whenever you get a request, a web request from a browser, or you have a worker start a command, you always want to generate a CID immediately at the very beginning. And you pass that CID in every single communication, and you log it in every single log. And what it allows you to do is you can go take all your logs, dump them into Elasticsearch, and if you find an error, you just click on, I want to see everything with this CID, and it'll show you everything that has to do with whatever that request was. This is called tracing in a lot of other systems, and I know there's a lot more complicated tracing that'll give you a lot more detail, but this is the most basic. This is pretty basic. You just do one ID, you pass it everywhere, and it's good enough for most tracing. It's not the most detailed, but you can probably figure it out. And yeah, that's it. Thanks for listening. So I guess I'm going to take some questions. There's some mics back here if anyone wants to line up. We're always looking for talent. So if you're interested in working on any microservices and any of this stuff, email tech@revpointmedia.com. Yeah.
How you doing? What are you using for your producers to dump the data to Kafka?
So we have Python producers. We're actually using Confluence. They make a Python wrapper around, I think it's librd Kafka. So it's the actual supported, developed producers. And so we actually had a little bit of an issue with, because it's a C package, it's blocking, and we have a bunch of asynchronous coroutines and things like that. So we actually had to move the producer to a completely separate process, and they communicate asynchronously via multiprocessing.
Cool. Did you also explore Apache NiFi for moving data as a processing stream from the data pipeline to X?
I mean, I've seen a little bit about it. I haven't really played around with it that much.
Okay, cool. Thanks.
Yeah.
With a series of microservices all going into the same data pipeline, it seems like making it asynchronous is a really difficult task. Could you elaborate on that if everything's going in the same data pipeline?
In the centralized pipeline, we have a Kafka cluster. And so it's a 36 hard drive, 6-node cluster. And it's not just one giant pipe. It's every single application for every single purpose generates its own stream. So we have hundreds and hundreds of Kafka streams, each with its own purpose. So we're not just dumping into one topic. Every little thing that we have to start producing a new type of data, we start a new topic in Kafka. So they all go through the same hardware, but to the software, they're all separated.
In the example that you gave where you had a change to your application affecting, for example, the database and then that flowing into your data pipeline, what sort of information is meaningful for the downstream systems that are consuming that? Is that like configuration management, changes, and sort of
This
like
one?
deployment? Yeah, that one.
All right, so sorry, what was the last part again?
So I'm just curious as to what sort of meaningful information are you pushing through that pipeline that the worker search and ETL processes are consuming?
Okay, sure. Yeah, so Kafka, the Confluent open source platform that they offer, has a bunch of tools. And that tool set is really what enables all this to work. And so one of the tools is Kafka Connect. And that's what connects the database. Any database changes automatically go into the pipeline. We have a bunch of workers that watch those database topics. And anytime there's a change made in the database, that knows to update the cache. And so they're completely separated. Another thing is we have workers that also watch the same topics. And a lot of things will read from Kafka and produce back to a different topic. So you can use it as ETL to transform your data and move it around. It's really just the central pipeline. Just imagine it as you have a connection to another service, but you don't know which service that is yet. And so you're just providing it. And then other things can tap into that stream and read from it.
Got it. All right, thank you.
Yep.
For operations that need to be done using a database transaction, do you distribute that across different microservices? And if so, how?
So with databases, it's a little tricky. Anything stateful, it's really hard to integrate into a microservices cluster, for example, our Mesos cluster. So we still use Amazon RDS for our databases and Redis and things like that. So that's a problem that's still being solved. With Amazon, they have elastic block storage that can be really fastly, dynamically added and removed from machines. So that's one way that they're looking at adding statefulness to microservices, but they really don't mix as of right now. That the technology isn't stable enough yet. So we're still using external databases and just connecting to those over the cloud.
Thanks.
Hi.
Hi. With your data pipeline, you say when a web app changes an object, it pushes it out to the pipeline. And I'm wondering how much your services have to know about each other's representation of objects. Do you
That's a
dump it
good
out as
question.
is?
Yes. So everything in the data pipeline has a schema. And the Confluent package comes with something called a schema registry. And that's a little microservice that sits. And so the producers have to know what the schema is. And so they tell the schema registry, here's my schema. The schema registry says, okay, here's your ID. It embeds that ID in the message, and every consumer is able to read every single message because it looks at the schema and can reference it. And it even has, you can even set settings on the schema registry. So you can say, I only want forward compatibility changes, or I only want backward compatible changes, or I want forward and backward compatible changes, or you can say, I don't care about that at all. And it'll block new producers from actually sending in if you have it set, I don't want to break compatibility.
Thanks.
Hey, how you doing?
Great talk, thanks.
Thanks.
In the beginning of your talk, you said that you wanted to wait until the logic was mature before you carved it up into microservices. Should you always wait until the logic?
You don't
is
have
mature?
to. No.
Okay.
For us, we had a lot of really interconnected, where it was referencing back and forth maybe 3 or 4 times. And so if you have a clean separation, or if it's not that much work to separate them, then yeah, you definitely want to do it. But you mostly want to go for the most obvious ones first. which are like your authentication, things like that that can just easily be referenced, because your business logic is, you really want some room to be able to wiggle and move in there. Unless you know for sure that this is exactly what the business logic is going to be, you don't really want to put a cut in it, because then it makes it really hard to make changes and put it back together.
Okay. Maybe a little bit different way of saying it is, would you ever start with microservices, or should you always do a first run through before you try carving it up?
Not of core business logic. I wouldn't do that.
Okay.
Yeah, because technology does not really dictate most of those changes most of the time. It's really, someone's
Right.
boss coming in and say, oh, we need to change it to do this.
Right.
So you can't really predict those kind of things, and you really want to be 100% solid of your business logic before you go and say, okay, now it's big enough to, this is going to do this piece, this is going to do this piece, and this is going to do this piece.
Right. Thanks.
Yeah.
Hi.
Hello.
So I was just wondering, as far as like the Kafka streams, how do you, or have you had any problems with them crashing? And if so, how do you manage that without obviously you'd want to report on it, but not have to?
Yes, so we
manually
actually
fix?
have a 6-node Kafka cluster, and every single topic, you have a replication factor. And so there's two settings. You have number of partitions and you have replication factors. So most streams have about 12 partitions, and those get distributed evenly. And we usually do replication factor of 3. So the data is stored 3 places amongst the cluster on different machines. And what that does is we can lose half of the nodes, and we still have access to all the data. And we've been running that Kafka cluster for 2 years. We've maybe lost a node once or twice, and we had no issues in production.
Cool. Thank you.
Mm-hmm.
2 questions quick.
Yeah, sure.
Are you running your Kafka cluster on Mesos right now, or is
No.
it separate?
So there's a little bit of a caveat to that. So
Sure.
when we started, our Mesos cluster was only 6 or 8 workers, or slaves or agents, as they're known. And so we couldn't really. It wasn't. If we lost one of those, we would lost 1/6 of our Kafka. So initially, we decided that since our Mesos cluster was so small, we built our own dedicated Kafka cluster. And with EBS, it's really nice because you just load 6 drives on each machine, and it's you get RAID-like speed on that. And so we just have a dedicated Kafka cluster, and that really hasn't given us any problems. But if you were doing some big stuff and you had 100+ nodes on your Mesos cluster, you could easily just launch Kafka on there, and you could lose nodes, and that wouldn't be that much of an issue.
And does Kafka support replication?
Excuse me?
Does Kafka support replication if one
Yes.
you lose? Okay, it does.
Yeah, and there's so Confluent
Right.
is the company that makes it. They provide an entire tool set that just allows all this to be super easy.
Cool. And real quick, do you use Mantle to actually deploy your stuff in production, or more
So
for
we
testing?
we use our own framework that's really, really, really close to Mantle. So we have a couple, and it's open source, and you download all the files, and you can tweak it yourself.
Cool.
But we have a couple key changes that are a little bit different. But for the most part, we try to, if we see Mantle making changes, we try to follow them because it just makes it easier to, there's community supporting it and things like that.
Cool. Thank you.
Yeah. Is that it? All right. Thank you, guys.